Generally, DSL or digital subscriber lines are used for connecting to the Internet, and the IP address of DSLs are not fixed and are often changed or randomized. So for that reason, we should know when the IP address changes and to what, so we can connect to those network devices. However, remembering this or checking for the changed IP address is both very difficult and cumbersome. A dynamic domain name system, also referred to as DDNS, will solve this problem. A DDNS is a network service that allows devices to change its IP address to a friendly domain name like samsungipolis.com/demo1. This allows easier access to that device. The user only needs to know the domain name, instead of trying to remember the differing IP addresses. To aid our customers, Samsung Techwin supports DDNS service called Samsung iPolis. If you register the DDNS username of the NVR on the iPolis server, you can connect to the NVR via the DDNS using your selected username, even if the IP address of the NVR has been changed. When using the iPolis DDNS service, first enter iPolis DDNS username on NVR DDNS menu. When connecting the router's ports, UP/NP select Quick Connect type Use. Next, you must register the NVR's domain name on the iPolis DDNS server. Finally, open the web browser and enter the URL address of the NVR into the address box. This allows you to connect to the web viewer via the NVR. Now you can see the main screen of the live viewer and live video streams from the network camera. However, when I'm at home, this is not possible to connect to those same cameras. The reason is that the NVR has to be connected to the outside world via a wide area network. To make this possible for both your home and your office, you must utilize a router. These are gateways to the outside world. A router has two IP addresses. One is the public address. As an example, 234.56.78.9 that can be accessed from the external network, the Internet. The other one is the private IP address that will not be routed over the WAN. Example 192.168.1.1. If you enter the 234.56.78.9 from your external network, your PC will connect to the router, but it will stop there as the router does not allow you to send a request from your PC to the next device. To solve this problem, we utilize port forwarding. Port forwarding transfers incoming signals from the router to destination devices which are connected to the router. there are potential 65,536 ways or ports into a network device. Because of this, we must inform the router which one of them we will be utilizing. This will then allow the router to forward the request to the correct port. We must first see which ports are being used by the NVR. The NVR's web page uses port 80 by default. However, it is recommended to use ports between 1024 and 65535, as port 80 is often blocked by Internet service providers, policy, or a local firewall. TCP/IP port is for transferring the NVR's video is defaulted to the port 554. Internally, 4 ports are used: 554, 555, 556, and 557. When 2 or more NVRs are connected to the same router, the web viewer and TCP ports of the NVRs must have a different set of port numbers. Once the port forwarding settings are completed, enter the hypertext 234.56.78.9:8000 into the URL address box of the external PC. This will start the connection to the web viewer on the NVR1 port. Then the connection goes to the router with the address 234.56.78.9. The router then translates that port number to 8000 to the internal IP address of 192.168.1.200 at the site of the NVR. It will then connect to the web viewer of NVR1. Then, to connect to the web viewer of NVR2, again enter hypertext 234.56.78.9:8080 into the URL address box from the external PC. This connection to the same router address of 234.56.78 and 9 translates that port number to 8080 to the internal IP address of 192.168.1.201. This is at the site of the NVR. This time, it will then connect to the web viewer utilizing NVR2.